Welcome to the 12th TAISIG Talks. I'm here as a co-host for Marie Postma. My name is Peter Spronk. Normally Emil Arts is sitting in this chair, but he couldn't be here today, so I'm taking over for him. May I ask the people who are currently in the link in the Zoom call to turn off your screens. You all have that, that's good, and keep your audio off because that would disturb the call here. We will have 2 speakers today. Normally we have 3, and that tends to be a little tight, so now we have a little bit more time, and hopefully we can go a bit more in depth for these talks. We will not go on longer than 6 o'clock, so this really will be between 5 and 6 o'clock. If you have comments during the talks, or you want to ask the speaker some questions, then write them in the chat. We will keep track of the chat, and we hopefully can get to these questions at the end of each of the talks, and maybe a few at the end of the 2 talks. Marie, over to you.
Thank you, Peter. So welcome everyone. Let me introduce the first speaker for today. That's Phillip Brown. Phillip Brown is a PhD researcher in the final stages of his PhD project that is being completed at the Department of Cognitive Science and Artificial Intelligence here in Tilburg under the supervision of Wendy Powell. His project focuses on the use of VR in various settings, primarily with medical applications in mind. As you may know, there's currently a lot of interest in VR applications, and there is a great potential for these developments, for instance, in areas such as education, health, and marketing. Now, what a lot of people don't realize until they start working with VR is that one of the issues that VR researchers run into is that a lot of users experience motion sickness, cyber sickness, while using virtual reality applications. So this is an issue because it concerns about 20% of normally developing population. And there are certain groups that are affected even more. Philip, in his research, focused on cyber sickness in particular patient groups and came up with results that are relevant not just for his own research, but for all of us who conduct studies in VR environments. Now, one thing that I really had to extract from Phil was information about his hobbies. And you know that in these TAISIG talks, we like to also dive into some of the personal interests of our speakers. Phil likes to go for walks. He likes to listen to music, but he didn't like to share information with us about which bands he likes. So that's something you will have to ask him personally. But he does like to play board games. And actually next to me, I have our, our university board game expert, because Peter is not just conducting research on games and serious gaming, but he also organizes a lot of game events at Tilburg University, one of them being a board game night. Peter, is there something you would like to say about these
Well, the board game nights, we try to do them live, usually in the Depré building in the center of Tilburg. We had to stop them for a long time for the last 2 years because of COVID, but I intend to very soon start them up again. So if you are interested in joining up, leave a message in the chat and I will write down your name.
And if you do join, then you may also find out about Phil's favorite board game that currently, that I understand involves animals and dealing and organizing animals or confining animals. Okay, so that much about Phil's background. Phil, please, the floor is yours. Tell us about your research.
Thank you, Marie. Hello, everyone. Thank you for the lovely introduction. My name is Phil Brown, Phil or Philip, whichever you prefer. And I will be talking to you today title was a bit messed up, unfortunately. That should say Recognition and Interpretation of Pain and Cyber Sickness in Virtual Reality. I'm a PhD student in the Department of Cognitive Science and Artificial Intelligence, and I'll try and give you a quick about me. PhD student with Dr. Wendy Powell. I transferred here from Portsmouth, UK in July 2020 during the pandemic. I previously worked as a research assistant at Portsmouth University, where I was working on projects such as VR molecular visualization and also VR meeting spaces for adolescents. My primary research interest, which I'll be speaking to you today about, is pain detection and alleviation and cyber sickness detection and interpretation. So first off, I'll sort of give you a real quick whistle-stop tour of the background of it and sort of dive down into the work, which is focused around my PhD. Firstly, in general, about pain. So how we actually process and why pain distraction, why virtual reality, sort of consequences of that, and the sort of problems I'm looking at answering as part of my work. So the easiest way I think of thinking about pain is that with our bodies in general, we send signals all the time. Some of these signals will be threatening, some of them are going to be non-threatening signals. And in the case of pain, if you hurt yourself or something happens which sort of knocks a stimuli, you're going to be sending a signal to your brain, which is then going to send a signal back and try and give you a defense mechanism to try and make you not do it again. Now, with virtual reality, where that comes in is based on something called gate control theory and how we can distract ourselves from pain. So in lots of circumstances with pain, you could take medication and things like this. However, there are also more non-pharmacological interventions that we can use, and pain distraction being one of these. Traditional methods aside from going into virtual reality, you can think of films, TV, reading books, and the idea behind this is that you can then provide non-threatening signals rather than threatening signals. And then what gate control theory proposes, and then this is how VR will slide into this, is there's an image on the right actually that might help explain some of this, is that when we receive these threatening signals and it travels up our spinal column to our brain to receive this signal, these theoretical gates will open and close. If it's a painful signal, this theoretical gate will open, and then that will send back the painful response. If it's a non-threatening signal, then it will hopefully keep the gates closed more often. And that's what we're trying to achieve. We're trying to keep these gates closed, so therefore we reduce the sensation of pain that the user is experiencing. So why VR and what sort of happens in VR? VR is fantastic at producing these non-threatening signals, so therefore keeping these theoretical gates closed more than they are open. And we put this down to the sense and the elicitation of presence, which VR is fantastic at. So if we are able to place ourselves elsewhere other than where the painful stimuli may be, and we are able to immerse ourselves in other environments, then we hope to be able to increase the sense of presence, thus reducing the threatening signals which are being elicited. The consequence of this is that virtual reality also makes people feel sick. Cyber sickness, also referred to maybe as simulated sickness, visually induced motion sickness. But the idea is that they are symptoms similar to motion sickness. So if you've ever tried virtual reality, you may know yourself, but you may feel sort of dizziness, nausea, headache. And this cyber sickness interferes with our sense of presence. So it's doing the opposite of what we want it to do. And instead we are producing more of these threatening signals, not enough of these non-threatening signals. Our theoretical gates stay open, the painful signal is being sent to us, which is undesirable. A bit of a sidestep here, but I think important to my work, especially how I'll explain it, is how we actually measure pain and cyber sickness. And most of these are done using self-report methods. There's an example of a pain self-report method on the right, just below the diagram. And we use scales. So normally for pain, for example, you can use stuff like numerical rating scales, visual analog scales, where you'll ask the participant or patient on a scale of 1 to 10, how are you feeling? And they'll give that answer. Cyber sickness, similarly, there are a few different methods, mainly self-report once again, although the most prominent being the simulated sickness questionnaire, 16-point questionnaire, scale of 0 to 3, asking you on a scale of severity how bad a certain symptom is, such as, like I mentioned earlier, dizziness, nausea, headache. So what problem am I trying to achieve in my work, knowing all of this information? Well, I initially went into this work from the perspective of what role VR has to play in distracting people from pain. So initially, and you'll see from my first study, which I'll go through in a moment with a couple of publications that came out of it, was concerned with what about VR is actually causing this distraction. we hypothesize and we theorize about the present side of things, and that if we feel more present, maybe we can provide more distraction. However, is that enough? What about the media is actually distracting? Do we need something engaging? Do we need something interactive? Is something passive actually able to produce this same analgesic? And then from that, with the results of that study and what I've gone on to now and what is forming the final stages of my thesis, is actually why we are using self-reports and maybe how we can look for alternatives to this. Number of reasons for this, and especially that I found through my own work, let alone the literature itself. It can be quite unreliable, can be very subjective. It can lead to bias, especially from experimenters as well. We can get gender bias in there. It can be quite undesirable, especially from a self-report perspective. It's quite hard to actually ask someone during an immersion how much pain they are in or how sick they are feeling. Once again, that sort of ties back around to breaking the sense of presence, therefore reducing pain, etc. And then also unfeasibility, very time specific. If I ask you post-intervention what has happened to you, you are using almost like a memory recall to tell me what happened. I don't understand what actually happened at that time. So there's a number of things around this as to why I am interested in using alternatives to self-report methods. So into my work to date. I will break this up into sort of publications which have come out of this thus far. But the way I'll try and construe this to you is that there was a small study which I did initially, which I spoke about, where it was examining VR's role as a distractor among persons. And this was specific with people with persistent and chronic pain. Further from that, with the work that came out of that, we are actually noticing irregularities, especially in cyber sickness reporting. So we made a further publication where we were looking at the extrapolation identification that the current theories concerning cyber sickness reporting may be incorrect. And then thirdly, during the pandemic, when human participant research wasn't able to go ahead, we actually elaborated on these results further. We conducted a survey-based study where we were examining potentially incorrect assumptions of cyber sickness baselines. So I'd like to go through this a little bit more in depth with you anyway and sort of discuss some of the results that we got from these. The first publication from this small study we did was titled Virtual Reality as a Pain Distraction Modality for Experimentally Induced Pain for a Chronic Pain Population. We had two hypotheses from this specifically. We were looking at whether the pain tolerance would differ between active and passive interventions, of which we found that people tolerated pain significantly greater in the active compared to a passive intervention. And then secondly, whether presence would be positively correlated with pain tolerance. So in this regard, we found significant positive correlations between presence and the active intervention, and then similarly, no correlation between pain tolerance and presence in the passive intervention. And so this answered the initial question I had with part of my thesis, or certainly started to build upon that, which was, what about VR do we need? Do we need it to be engaging? Is it enough just to wear a headset? Is it enough to, what part of this do we actually need to identify as being the distractor? And in this case, it was very clear that the medium of VR itself isn't a sufficient distractor, and that the media is actually important to this. But furthermore, especially with the work that I'm doing now, what was identified is that the use of self-report questionnaires is not necessarily ideal methodologically, and this sort of builds into the next publication, which I have. So the following publication, based off the same data set of the same participants, was titled Preexposure Cyber Sickness Assessment Among Clinical Populations of Virtual Reality. So as a quick background, again, when you administer something like the SSQ, if you're not familiar, that's Simulated Sickness Questionnaire, you will traditionally ask them post-intervention, and you use a pre-intervention assumption that people are coming in with a 0 baseline score. So you can assume that everyone is feeling perfectly healthy before they go in lieu of some experiments which may ask people or may actually exclude participants if they are feeling anything other than healthy, which you can imagine with maybe a pain population isn't indicative at all, because you're going to have people coming in showing symptoms which will probably correlate quite highly to some of the symptoms we're asking on questionnaires. And so that's what we were actually looking at here. Is that 0 baseline correct? Because what we found, especially in our small participant pool, is that was incorrect. So the main two hypotheses that we actually got out of this, specifically, we were looking at whether the pain population have significantly higher pre-exposure scores than the normal assumed baseline. Now, this was fairly much a given based on the work we have previously done, because in the table to the right, you can see the pre-exposure, post-exposure scores of the 12 participants we had in this small study. Only 2 of them actually exhibited a 0 baseline, meaning that every other participant actually entered with a non-zero baseline. And then furthermore, we were actually looking at the differences between the assumed baseline and our actual known baseline. And what we found here is that the differences between the assumed baseline and the post-exposure scores was significantly greater than the difference between the pre and the post-exposure scores. And what this was actually trying to highlight, this result, is that if you use an assumption, you are going to get drastically different results than what you would actually, if you collected, say, a pre-exposure, what that actually indicates. We conclude from here that non-zero SSQ baselines were reported amongst main populations, and assessing based on an assumed baseline may be incorrect, may incorrectly conclude that heightened side sickness was experienced. Now, there's a couple of parts with this. It's why we followed on with the survey-based study afterwards, which I'll flip to now. And this was a study which we conducted amongst a much more general population, and it wasn't a specific pain population. So this publication, which is just coming together now, which is about to be submitted, and this is tentatively titled The Simulated Sickness Questionnaire and the Erroneous Zero Baseline Assumption. Now, what we did here is we actually recruited just under 100 participants, and we asked them at a time of day which would mimic study conditions for a virtual reality study to take the simulated sickness questionnaire. We were not eliminating participants based upon any health condition. Instead, what we actually did, we asked for disclosure of any predetermined health conditions or medication which they were taking, and therefore we would group them afterwards as being part of either a healthy or a medical population. And what we were looking for here is this zero baseline existing in the general population? We hypothesized that it wasn't. We hypothesized based on our previous work as well that our study sample would be higher, significantly higher than our zero baseline assumption, which was correct. We also hypothesized further that the healthy subpop would be greater than zero baseline, which we found to be true. Similarly for the medical subpopulation, which we found to be true once again. But one thing based on our previous work, which we were looking at, or what we thought anyway, was that medical subpopulations, for a number of factors, such as medication use, again, confounding with simulated sickness, answers or questions which are being asked, status of the health condition itself, which may confound also, we thought that they would actually score significantly greater than healthy subpopulations total scores, although we found this to be incorrect. If you see on the right, the violin chart at the top is the actual distributions of the participants, and you can see they're actually very similar. Although healthy participants did on average score less than the medical population participants, it's certainly not a zero baseline, and it's actually nowhere near. If you look at the table down towards the bottom, only 3 of our 93 participants actually did score a zero baseline. The vast majority of them, you can see 73% of them actually scored higher, and then based upon the initial publications, categorization of how good a intervention is would be categorized as having a bad intervention. And this is before anyone's even conducted or anyone's even gone through a virtual reality intervention. So it's not great as far as from this population anyway. And what we do conclude from this is that non-zero baseline scores in medical and healthy populations observed. A couple of caveats again to this though, however. This was a predominantly student population which we recruited from, and this was also during the COVID-19 lockdowns. So it could be said as well that people could be answering more skewed towards some of the questions, which could be, for instance, difficulty focusing and fatigue-based questions. So that could be something to actually explore further in the future. And especially as well, since there wasn't any priming that they were going to be experiencing a VR intervention. So there could be sort of some different questions being answered there. Now I'd like to sort of flick on to what's happening now alongside this publication. I'm also just about to start the final study on my PhD. And for this specifically, we are hopefully not doing away with the self-reports, but we're hopefully going to be start implementing some more physiological measures to infer pain and cyber sickness. A lot of the literature, especially for pain and cyber sickness, suggests that we can indicate, maybe not at the moment how much they are experiencing, but certainly elevations of these. The most proposed at the moment are with heart rate variability and electrodermal activity, specifically in conductance, although the literature will highlight that both of these are relative to pain and cyber sickness. So especially if we have an intervention where we are trying to look at both, these two alone aren't necessarily going to be indicative of what's going on. So we're proposing actually including some other physiological indicators such as eye blink rate and pupil dilation, which may be better inferences of identifying what is elevated when both occur. And furthermore, we're actually going to be using EMG facial responses, specifically from corrugator and frontalis muscle movement to try and indicate whether we have elevations in pain or cyber sickness. And these will then be correlated with their self-report counterparts. So also what is happening is that I'm involved in a WeCare funded project aptly titled VR for ER, where we're actually looking at novel applications of pain distraction within emergency room departments. This is just starting at the moment. It won't conclude for about another year, but we are hopefully going to be incorporating as well some pain identification modalities using physiological methods within an emergency room setting. And I think sort of blitz through that a little bit, but I think that's most of the work that I've actually got so far. So I'm more than happy to answer any questions you might have. And thank you very much.
Thank you, Phil, for a very interesting talk. So just to ask a question about cyber sickness. It's something that is triggered by the use of the VR headsets.
Yeah.
And also what's happening in the simulated environment, but is there also something in the movement of the user that can actually increase the experience of cyber sickness and maybe also alleviate it? So I'm thinking about particular movements of the head.
Yeah, so what we actually also hypothesize from the cyber sickness perspective is that it's actually the imbalance. So the fact of when you have movement happening virtually to you, but then you're actually stood in the same place, your body can't actually comprehend what is happening. So it makes you feel like the stomach's almost going up inside of you because you are not able to regulate that movement to what you are seeing. So what is happening now is actually some researchers looking into moving platforms, for example, where there'll be the vibrations or movement so that it will not feel so disproportionate between them.
Okay, but we would need extra equipment for that. It's not
Yes,
something
most
that
definitely.
we could design as a feature of the simulated environment so that we, for instance, use head tilt to...
Yeah. No, and again, specifically where you'll find this happening more so is, say, in environments or in applications whereby the user will not be moving of their own free will and the camera will maybe be moving through the environment for them. Again, it's that displacement and that irregularity between what you are seeing and what you are feeling and then what is actually happening to your body. Other things that are being used, there's actually a WizDish in the corner of our room where we've got walking platforms, which are hopefully alleviating this as well. So not just being used these things as sort of movement technologies, but actually as alleviation as well.
Thank you.
Yeah, so what kind of applications would you use in that emergency room to alleviate pain? That was what I was thinking about.
So it's difficult as well. So specifically for the project that we're looking into, it will be ankle breaks, dislocations. So you do not have your hands available to you. You might have an IV in one hand and your other one's broken or dislocated. So at the moment, what we're exploring using, there are very passive experience with 360 videos, there are animations as well, and there are certain applications as well which you can use eye gaze direction as well to actually navigate around it. So they're not interactive maybe in the sense of VR as we think they are. However, they still need to be engaging enough because you still want to capture that sense of presence. You still want people to be engaged and again, reduce those non-threatening signals. So won't be completely passive, but it won't be as interactive as maybe what we're used to.
Thank you. Is there a question in the chat? So it's somebody says, thank you for sharing your insight, Phil. I work in the industry where VR and AR devices are used in support of everyday operations of business. Based on your studies, do you expect similar results for AR devices?
I'm probably not the best person to speak by AR devices, unfortunately. I'm not sure myself. I haven't looked into so much of the literature, especially from a cyber sickness perspective with AR. I wouldn't have thought so quite so much because you do have, especially with AR, the perspective of things around you. So like I said before about that imbalance between movement, you're actually able to regulate that a lot more, I believe, in AR. But again, I'm probably not the expert to regulate that.
Thank you. I think we have to go to the next speaker.
Thank you, Phil.
Thank you very much.